Today we are going to discuss about the topic modern block ciphers. So modern block ciphers is mostly widely used type of block ciphers for the cryptographic algorithms. So it is mostly dealing with it provides the secrecy and also authentication services. So one of the algorithm is data encryption standards, and also you have the AES algorithm which applies the block ciphers. And to illustrate the design principles of the block ciphers, we need to know about what is meant by the block and the stream ciphers. So block cipher process messages in blocks, each of which is then encrypted or decrypted, like the substitution on a very big characters of 64-bit or more. So we are going to take the block size of 64-bit or more. Then stream cipher is a process of message a bit or a byte at a time when encrypting or decrypting. So many current ciphers are the block ciphers because they are better analyzed and also the broader range of application. So what is the block cipher that we have already seen? We have seen the playfair cipher. Then what is the size of the block size? The block size is there 2 characters. Is it not? Now coming to the stream cipher. What are the stream cipher that we have seen? We have seen the Veneer cipher, one time pad ciphers. Then how this block cipher and stream cipher works? So we have already discussed how the stream cipher will work. So a stream, that is a plain text, is being taken and each of the bit is applied to the key and we are going to get the ciphertext. So similarly at the decrypting end we are going to apply the key algorithm, that is bit stream generation algorithm, and we are going to give to the ciphertext, then we are going to get the plain text. In the similar manner, when it comes to the block cipher, we are going to take the plain text of B bits, then we are going to apply the encryption algorithm with the key and we are going to get the cipher text. So coming to the block cipher principles, most of the symmetric block cipher principle based upon the Feistel structure, Feistel cipher structure. So block cipher look like extremely large substitution. So it would need about how much, if at all we are taking 64-bit block, so how much is the table entry? 2 power 64 table entry is needed. So instead of that, we are going to break down that particular blocks into the smaller building blocks and we are going to do. So how we can do? So we have the principle, they have developed an international data encryption algorithm. In that algorithm we can see that they have taken the 64 bit and this 64 bit is divided to the blocks, and we are going to see where each block will contain about how much, 16 bits. So you can observe in the diagram, that is ideal block cipher, that is the international data encryption algorithm block cipher. So here they have taken 4 bit as an input which contains, that is the input 1. So total 64 bits. We have 64 bits. So those 64 bits are divided into 4 blocks. So how many blocks you can have? So each block, how much amount of data you contain? So 16 bits will be there. So these 16 bits are again done in a form of a permutation. Then we are again going to get 16 bits as an output which relates to the 64 bit of output. You can observe in the algorithm, that is we have taken the input of a 64 bit, then each plain text is divided to 16 bits. So 16 bits in the plain text 1, plain text 2, plain text 3 and plain text 4. So 4 blocks we have, each of a 16 bit. So in the round function we are going to apply the key. These are keys, you can say as a sub keys. Okay, so how many keys we have? We have the keys about 1 to 52. 1 to 52. So at the each round we are going to apply the keys and we are going to get. So this is the sample on how many rounds we are going to apply. So we have about 10 rounds that we are going to apply, and we are going to get the output as a ciphertext. So at the for the plain text one, we are going to apply the 10 rounds and we are going to get the ciphertext after those 10 rounds. Similarly for the plain text 2, similarly for the plain text 3, similarly for the plain text 4. Now coming to the how the substitution and the permutation ciphers came into. So the Claude Shannon introduced the idea of substitution and the permutation, or we can also say as a SP network, in 1949. So it is a form of a modern block ciphers. So SP nets are based on two primitive cryptographic operations which are seen before. One is the substitution, another one is the permutation. So we have seen two substitution as well as the permutation. So substitution we can say as an S box, and permutation, that is transposition or rearrangement, we can say as a P box. So this provides the confusion and diffusion of a message and key. Then what is confusion and diffusion? So whenever you provide these S boxes and P boxes, the cipher, whenever you apply to the plain text get much harder to the attacker to know whether to it get complex whenever you apply these at the each round. So the complexity increases, the attacker does not know how to retrieve the data which is being applied. So to break down that particular algorithm will be very difficult whenever you increase the number of rounds. So this provides the confusion and diffusion. So confusion is related to the substitution and diffusion is related to the permutation. Then coming to the confusion and diffusion, the cipher needs to complete the obscure statistical properties of the original data. So whenever you are getting the cipher text, that cipher text should be in a form of a hidden manner such that it should not reveal about the original message. And this is only can be done in one method, that is one time pad, where we are going to generate the that at only that present of period of time where the key is generated and we are going to get. But if you are applying the data, so it should be in a form of a confusion and a diffusion. So more practically, the Shannon want to have the SP combination of elements. So he defined that the diffusion dissipates the statistical structures of plain text over the bulk of ciphertext. So dissipates is nothing but it eliminates the structure of the plain text from the ciphertext, and confusion makes the relationship between the ciphertext and the key as complex as possible. Then coming to the what is meant by Feistel cipher structure. So Horst Feistel devised the Feistel structure. So based on the concept of the invertible product cipher. So in this Feistel cipher structure, so the total plain text is divided into two halves. So what does it does? It processes through the multiple rounds which perform substitution on the left half, and based on the round function of the right half and the subkey, then the permutation and swapping halves. So how this can be done, you can see in the next diagram. So see here, so the Feistel cipher structure will look in this format, that is the total plain text will be divided into two halves, one on the left side, another on the right side. So on the left half we are going to provide with the S boxes, okay, and on the right hand whatever the data is there, that data we are going to apply the function and also the round key. And directly this particular right side of the data will go to the next left. So the swapping happens whenever you are performing the right side of the data. We are going to apply all the function on the right of the data, and we are going to, for the next round, directly this right side of data will be given as the left side, and whenever you are applying the round function, that is function as the round key, then XORed with the left half of the previous one will be given to the right side of the next round. Okay, so this type of structure you can say as a Feistel-Cipher structure. Okay, now depending upon the algorithm, the number of rounds decides. So, like an example of the previous, like I said, the international data encryption algorithm have 10 rounds. In the DES algorithm, you have about 16 rounds. So, based upon the number of rounds, this particular structure will continue till the number of rounds are being said. Okay. Now, when you are increasing the number of rounds, the complexity of the ciphertext to break down is also increased. So for that reason, we can see that the number of rounds depends upon the algorithm. Then the design elements in the Feistel cipher structure is, these are the design elements. So what is that? Block size. So it depends upon how much is the block size that we are taking. If you are increasing the block size, then you can say the ciphertext also becomes the that is the process become complex, but it is revealing may be easy. So you have to remember that the confusion diffusion may occur. So most of the time limited to particular block size is very important. Then also key size. The whatever the block size that we are taking, we are also taking the same key size, and whatever the key block size we take, the same amount of the block we are going to get in the ciphertext. And like I said, depending upon the algorithm, we are going to have the number of rounds. Then sub-key generation algorithm. So the number of rounds also generates the number of sub-keys. So here in the 10 rounds, how many keys we generated? Since we have applied the plain text of 4 in the idea, so we have applied about totally 52 sub-keys. Then coming to the round function. So round function contains the, it can be of XOR, it can be of a substitution values, or it can be of a permutation values. So this, applying these elements, it can be of having the software with the encrypted and the decryption. So it also have the easy of analysis when you use this Feistel cipher. Thank you.